Good question. So, you develop a 0-day by identifying the target, providing lots of different input, which we call fuzzing. You provide inputs until you cause crashes. So if you're dealing with an email server or a VPN appliance, you basically look at, let's take the email server, because it doesn't say which it is. What does the email server do? Is listening on TCP port 25. So I take this appliance and I start shoving input in there. See if I can cause it to crash. See if I can cause it to crash. That's the fuzzing part of it. Initially, see if I can make it do things that are just unexpected. Then, once I can cause a predictable crash, then I start looking at how it crashed. I do memory dumps of the process. Right? I take the crash dump and go and analyze it. And there's actually the typical thing that you would inject in when you try to look for a buffer overflow is capital A. So what you're looking for is a return pointer in the crash log that says attempted to execute memory instruction 41414141, which means that my capital A's got into the return pointer for a particular function. And then I assess and say, what function was that? And then after I figure out what function it was that I managed to crash, then instead of just putting capital A's in there, then I actually build exploit code that I'm going to put in there instead. So then I'm going to provide my input, I'm going to overwrite the return pointer, and hopefully return into the code that I've just added. Now, if I'm dealing with a tool that has data exploit protection DEP in place, then I have to go look for a ROP chain, where instead of running my injected data, I'm actually going to look for other executable instructions that are in place already in executable that I can use. And if they have address space layout randomization in place, then I need to find things that are not effectively randomized in order to use those. Maybe I use a structured exception handler overwrite strategy. There are a couple of different ways that I can circumvent DEP and ASLR, but this is how you write. This is how you write the exploit. Basically, look at the sequence, cause a crash. When you cause a crash, you figure out how the crash was actually triggered, and then you go and build an exploit from it. And then you test and test and test and test and test and test until it's just right.